So before we talked about velocity, and we talked about the average velocity. So why is it an average velocity that we're talking about? Well, the reason is because we can have a velocity that changes, right? When we talked about Newton's first law, we said that the velocity at some time, say t0, if we look at this same particle later on, if there's been no interactions, then v at t at some later time is still going to be the same velocity, right? But there could be some interactions that are changing our velocity. And so we're not going to look at the details of how velocity changes yet. We'll do that in a couple videos. But first we're going to look at different ways in which the velocity can change. So for example, let's say we see a car that's stopped at a stoplight. Okay? So at time t equals 0, let's say we see the car at x0, which is just equal to 0. Okay? And then at some later time, so we'll say that this is t is 1 second later, we notice the car is at x1, which is going to be equal to 1 meter. Then we click our stopwatch again. We notice that when we get to t is equal to 2 seconds, now at x2 we're at 4 meters. And then when we get to t is equal to 3 seconds, our position x3 is equal to 9 meters. So now let's look at our velocity during these different time intervals. So in this first interval, between 0 and 1, the velocity in the x direction is 1 meter. We want 1 meter in 1 second. So the velocity is 1 meter per second. Okay, in the second time interval, between 1 and 2, v12, the change in position is 3 meters. The change in time is 1 second. So now our velocity is 3 meters per second. In the last part, in the next time interval, so v23, we notice that the change in position is 9 minus 4 is 5 meters. Again, still in 1 second. So velocity is 5 meters per second in the x-hat direction. Okay, so that our velocity, our average velocity, has increased during each time interval. And notice specifically that the velocity that we've chosen here as a function of time is just the time squared x-hat, right? But I can't just say time squared because this is in seconds, and I need something that's in meters per second, which means I have to multiply this by a meters per second cubed, so that when my time in seconds is squared, it gives me something in meters per second in the x direction. So this is the velocity I have as a function of time. And what it means is if the velocity is just in one direction, right, but in time the magnitude of the velocity is changing, right? It's, you know, if we look in each of these cases, the vector components of velocity haven't changed at all, right? In the first case it's in the x-hat, in the second case it's in the x-hat direction, in the third it's in the x-hat. There's no other components of it. So it's actually the magnitude of the velocity is changing with respect to time. In the next video we're going to look at a different way that velocity can change, so that the magnitude of velocity can actually stay the same, but because it's a velocity, it's a vector, we'll see that actually makes a difference in what the velocity is.